In this video, we solve the numerical of loss of head due to sudden enlargement. First, we understand the problem statement. The rate of flow of water through horizontal pipe is 0.25 meter cube per second. Rate of flow of water means Q is given. The diameter of the pipe, which is 200 mm and suddenly enlarged to 400 mm, means D1 and D2 is given. This one is D1, this is the D2. The pressure intensity in the smaller pipe is 11.772 Newton per centimeter square. Pressure intensity in a smaller pipe means it is the P1 is given, and we need to find out the loss of head due to sudden enlargement means we need to find out the HE. Seconds, we need to find out pressure intensity in a larger pipe means P2. So P1 is given here, we need to find out this P2. And power loss due to the enlargement means we need to find out the PE. Okay, for finding out this power loss due to enlargement, first we need to calculate this HE. Now we write down this given data. First, Q is given, it is a 0.25 meter cube per seconds. Second, D1 is given 200 mm. So we need to convert them in a meter, means it is divided by 1000. 200 divided by 1000, we get this answer in a meter, it is a 0.20 meter. Second, diameter of larger pipe D2 is given, it is a 400 mm. So 400 divided by 1000 is equal to 0.40 meters. Pressure intensity in the smaller pipe P1 is given, it is 11.772 Newton per centimeter square. We need to convert them in a Newton per meter square. So in a 1 meter, that is a 100 centimeters are there. Okay, so here it is a centimeter square is there. So when we convert them in a meter square, so it is again multiplied with this 100. So this is 11.77 into 10 raised to 4 Newton per meter square. We need to find out HE, P2 and the P, or we can also say it is the PE, power loss due to the sudden enlargement. So first we find out the HE. So loss of head due to sudden enlargement, it is denoted as the HE, and equation of the HE is in bracket V1 minus V2 bracket over square upon 2G. G means it is gravitational acceleration, value is 9.81. But here V1 and V2 both are not given, but we are able to find out the V1 and V2 by equation of this Q. What is the Q? Equation of the Q. Q is equal to area into velocity. So here area is not given. So we are find out this area from this diameter. So if the pipe is circular, then equation of this area is pi by 4 d square. So we find out this first area A1, that is pi by 4 d1 square. Value of d1 is 0.2. So we get this answer of A1, it is 0.03141 meter square. Second, we find out the A2. A2 is equal to pi by 4 into d2 squared. Value of the d2 is 0.4. So here we can do the square of 0.4s and also multiplied with the pi and 4, then we get this answer of A2. So we just simply calculate in a calculator, we get answer of the A2, it is 0.12566 meter square. So V1 is equal to Q divided by A1. From these equations we need to find out this V1. So this area is supplied in the left side, so it is Q divided by area is equal to velocity. So V1 is equal to Q divided by A1. So value of the Q is 0.25 divided by A1. So A1 we already calculated, it is 0.03141. So we find out this V1. V1 is equal to 7.96 meter per second. Second, we find out the V2. V2 is equal to Q divided by A2. So we putting this value of Q and A2. Q is equal to 0.25. A2 is equal to 0.12566. So we get this answer of V2, it is a 1.99 meter per seconds. Now we have a value of V1 and V2. We putting in this equation. V1 is equal to 7.96, V2 is equal to 199, and we solve this equation in a calculator, then we get this value of HE. HE is equal to 1.816 meter. So here we find out this the head loss due to sudden enlargement. Now, before moving towards the find out the P2 and P, I request to like the video and subscribe my channels for watching the more video related to FMHM as well as other subject of mechanical engineering. For FMHM, various link is provided in descriptions as well as in car. For other subject, I request to visit the playlist. Now, second we need to find out the P2. For the find out the P2, we need to use the Bernoulli's equations. So applying the Bernoulli's equations before and after the sudden enlargements. So equation of Bernoulli's equation is the P1 square upon rho g plus V1 square upon 2g plus Z1 is equal to P2 upon rho g plus V2 square upon 2g plus Z2 plus He. Here Z1 and Z2 is not given, so we can consider the pipe is horizontal. So this Z1 and Z2 is cancels and we need to find out this value of P2. Okay, so first we find out the P2 upon rho g, then after we find out the P2. Okay, so when we cancel the Z1 and Z2, we get this equation. Then further we convert these equations in a terms of the P2 upon rho g. Means from the right sides, other parameter is supplied on the left sides. Okay, so this is supplied here on the left sides. So what is the equation? Equation is the P1 upon rho g plus V1 square upon 2g. This step is going on the left side, so it is a minus V2 square upon 2g minus He. Now we putting this value of P1. So P1 is the 11.77 into 10 raised to minus 4 divided by rho g. Rho is 1000, g is 9.81 plus V1 square upon 2g. V1 is 7.96 square divided by 2. Value of g is 9.81 minus V2. Value of V2 is the 1.99 square divided by 2 into g means 2 into 9.81 minus He. He we already calculate and the answer of the He is the 1.816. Okay, so we putting this value here in this equation and we simplified it. So this step is equal to 12. This step is a 3.229. This step is 0.209 and this is minus 1.816. Further we simplified, then we get this answer of P2 upon rho g. Okay, this is the P2 upon rho g is equal to 13.21 meter of waters. But we need to find out the pressure intensity, means we need to find out the P2. So this rho into g is supplied on the right side, means it is multiplied with 13.21. So 13.21 into rho into g. Rho is equal to 1000, g is equal to 9.81, then it is converted in Newton per meter squares. So we get this answer of the P2. Okay, here we again multiplied with 10 raised to minus 4, then we get the answer in Newton per centimeter squares. So we multiply this all this value in a calculator, then we get this answer of the P2. So P2 is equal to 12.96 Newton per centimeter square. Suppose here we are not multiplied with 10 raised to minus 4, then we get the answer in Newton per meter square. And last we find out the power loss due to the sudden enlargement, and equations of the hydraulic power is the rho g q into h. Okay, so here we need to find out due to the loss of enlargement. So instance of h, here we use the He. Okay, now we putting this value of all these four parameters. Rho is 1000, g is 9.81, q is given 0.25, He we already calculated, it is 1.816 divided by 1000. So we get this answer of P 4.453 kilowatt. So here we are find out our all these three parameters. So thank you for watching this video. If you learned something, then like the video and don't forget to share with your friends, and also subscribe my channels for watching the more video related to mechanicals engineering.